About every 2 years, the semiconductor industry substantially improves the way it makes integrated electronic circuits, also known as chips. Essentially, they make those smaller, more capable, faster, and require less power to operate, basically at the same cost as previous generations. Now, they've been doing this for decades, improving technology in this way every couple of years. One of the major challenges, however, is that these new technologies have substantial unknowns that lead to chips that simply do not work. It's common that only a handful of chips operate properly out of every 100 that are fabricated. A major project in our lab that addresses this challenge is designing example chips, also known as test chips, whose sole purpose is to actually bring back feedback about why chips don't operate properly. We have worked on this project for about 2 years now and published about a half a dozen papers on the topic. Now, this type of work is not meaningful unless you actually fabricate example chips. So we work closely with industrial collaborators to actually fabricate examples of our design and are very close to actually having hundreds of instances of this chip made in 7nm technology. The main challenge is to design a chip that's actually transparent to the fabrication process, but at the same time is representative of all the designs that will be fabricated in the future. As far as we know, we're the only academic researchers in the world working on this problem. If we're actually able to do this well, it means that new chips will go into phones, cars, tablets, anything that utilizes electronics in a way that is actually very cost effective. This is extremely exciting work. Very few researchers in the world can say that they have access to state-of-the-art technologies from a real industrial partner. It's extremely satisfying for both myself and my students to work on such a project.